Good morning. Today we shall be using Aspen Hysys version 8 to solve a problem involving recycle and separation processes, taking Toluene Production as a case study. Now, let's take a look at our problem statement. Toluene is produced from N-heptane by dehydrogenation over a Cl2O3 catalyst. The reaction is between N-heptane to give toluene and H2. The Toluene production process is started by heating N-heptane from 65 to 800 degrees Fahrenheit in a heater. It is fed to a catalytic reactor, which operates isothermally and converts 15% of N-heptane to toluene. Its effluent is cooled to 65 degrees Fahrenheit and fed to a flash separator. Assuming that all of the units operated at atmospheric pressure, determine the species flow rate in every stream. And the first step is to open a new case. You click on File, select a new case. It should take some seconds to load. Now, our next step is to add our components. So our component here shall be heptane, toluene, and H2. So let's go and add the three components. So you click on Add. Then you search for toluene. Click on Add. Then you search for the other two components as such. So N-heptane, add. So the next step is to choose a fluid package, but our fluid package in this case shall be penglobicin. So we search for penglobicin like this. So we go to the simulation environment, which will display our object palette. So from the questions we can see that our object should be so let's call the inlet the feed, and outlet the R feed, that is the reactor feed. So we can call the energy, the heat duty. So we can close that one. Then we select the next object, and next object, which is the conversion reactor. You click on it, then add. So our feed in this case shall be the R feed. Then we can call the vapor outlet, that is the top product. We can call it the R product, that is the reactor product. We can call the liquid outlet the R bottom, that is the reactor bottom product. So we are free to close that one also. So, but let's call the energy the R duty, the reactor duty. So it is displaying an error message at the bottom that it requires a reaction set. So, but we are here to add the reactions to it. So we go back to our property in order to add reaction. Then we now come back here to feed in our reaction. So we click on properties, then reactions. So we add the reaction set by clicking add. You can decide to rename our reaction set. So let us right click on it and change it. So we call it the toluene reaction set. So we add a new reaction. So select add reaction. We then double click on reaction 1. Then our component in this case are toluene, hydrogen, and N-heptane. As stoichiometric coefficient, we are calling the product a negative sign. So let's give the product a negative sign. So our toluene ought to be -1, since it's a product. Our hydrogen will definitely be -4, while our N-heptane will be 1. So our balance area is 0.0, and our conversion rate is 15. So we are good to go. So the next step is to add it to a fluid package. We add set to fluid package. And so we go back to the simulation environment. So we click on the reaction for the reactor. So we select Toluene reaction set and we are good to go. So we then add the next, which is a cooler. Our product, our outlet will definitely be S feed, that is the separate of it. We know we are still going to separate the outlet. So our energy, let's call it the C duty. So we then add the next object, which is a separator. So you search for a separator now. Separator is supposed to be under common, so that is it. You click on it, then plus sign. Our index here will be S feed. Our vapor product, we can call it the vapor or VAP, and our liquid outlet, we can call it LIQ. It definitely be the liquid. So we are free to close that one also. So the next step is to open our workbook in order to insert all the given values so that we can arrive at our answer. So here is our workbook. So our feed temperature is 65 degrees Fahrenheit and we are heating it to 800 degrees Fahrenheit. So hence our R feed will definitely be 800 degrees Fahrenheit. So we double click. No, you just have to click it once. Then add 800. So our inlet pressure is 1 atmosphere, which is the same thing as 14.7 psi. So we go for 14.7. Since our unit is inside. So our molar flow rate, let's call it 100. Then we enter our mole fraction, but we should have only one for heptane, since heptane is the only reactant. Now our R feed will also be at room pressure, which is 14.7 at atmospheric pressure. So our S feed will also be at atmospheric pressure 14.7 psi. So our R products now will also be at the same temperature as the R feed, which is 800, and our bottom will also be 800 since there is no intermediate cooler. So our S feed now, our S feed will definitely be 65 since we are cooling to 65 degrees centigrade by this of the cooler. So other values have been computed. Now let's go back to the question in order to determine what our question is. The question is determine the species flow rate in every stream. So we go back to the question, then we double click on the feed on the molar flow values. So we double click on it, then you click on more flows. So that is the species flow rate for the feed stream. So double click on the R feed also, click on more flow. So that is the species flow rate for the R feed. So you do the same for others in order to determine the species flow rate. So we are done. So let's go back to our main flow sheet. Thanks for watching this tutorial. You may decide to view some of my other videos, and if there is any form of problems, suggestions or corrections, just contact me and I shall reply.